Hello guys and welcome. In this particular video we'll be going to see TreeMap's internal. So first of all I want to tell you that TreeMap implements navigable map, okay, and TreeMap is not based on hashing. So I'm writing here and I'm cutting it down. It does not based on hash code and hashing, although TreeMap stores key value pair. Okay, so now we will see that how key values are stored. So as the name suggests, tree map, so you can guess by now that there has to be a tree data structure used internally. So what does tree map use? Tree map is red black tree based navigable map implementation. Okay, so now red black tree in itself is a big topic which we are not going to cover here, but here you can see that RB tree is a kind of self-balancing tree. Okay, so you should be remembering that. Now what is the property of tree map? So in tree map, entries of that which you'll enter key and value, they are sorted in natural ordering of its keys. So whatever keys and value you will put, TreeMap will always put it into a sorted form, natural or ordered sorted form, and that will be based on keys, not value. So let's suppose if you have entered as key 1 and value Ashish, and key 2 value Gupta, let's suppose, and then you have written 5 and said that XYZ, and then 3 PQR. So by default, when you iterate this, you will get Ashish, then you'll get Gupta, then you'll get PQR, because 3 will come when sorted. Although you can reverse sort it also. You have to provide collections dot reverse in the constructor. So that's another thing. That's purely a theoretical base. You can go and read. So this is how it will come when you iterate. So this particular collection stores the values in sorted order of their keys. Now the question is, let's suppose if you have a kind of like a string or integer or float, etc., so a type of key, then it will be, it's very easy for TreeMap to recognize that which is smaller than what. But let's suppose if you are giving a key as custom object, like you are making some employee class, okay, and you are saying that instance of this employee class will be key, then what will happen? How will you do that? So there are two ways to do that. I mean, to provide the sorting Why we need that? Because tree map will not be able to understand that which instance of employee is greater than the other instance of the employee. So you have to provide that definition. So there are two ways. One is you can implement comparable interface in the class. In our case, this is employee in the class used for keys. Okay, so here in our example, this class will be employee. You should implement the comparable interface in employee and override its method and provide the definition that which uh, instance will be greater than the other one. That's how actually the tree map get to know. And the second way is, so before going to first second way, I wanted to tell you that if you don't know what is the difference between comparable and comparator, you should be focusing on that also, and you should read it carefully, even though I'll make a video later uh, which will differentiate what is comparable and comparator. It's a bit confusing for few of them. The second way is obviously is you can supply an implementation of comparator. That would do comparing of keys. I mean, that will do comparing outside key class. I mean, when you will be like you will be writing the tree map, you can even pass the comparator here itself like this. And there will be a method overridden it which will tell that what is the natural what is the ordering of those keys will be. So that's how you can do. Either you can implement a comparable in the class itself, key class itself, or you should be providing external comparator into the constructor of tree map while declaring the tree map. And failing to do so will give you a class cast exception if you'll not provide the natural ordering for these, because tree map itself will not be able to judge that which employee object is greater than the other one. Now coming to how does a node of tree map looks. So here you should be imagining like this. You already know how does the tree node looks, but here remember I'm drawing it for your convenience. So this is obviously, this will be left, as this is a binary tree, this will be right. So there will be left and right child of tree. Okay, and now what things will be there? There will be obviously key, because we are storing key. Okay, and there will be value, which we already have guessed by. But what is this third element? So this third one will be color. Why color? Because you can see that we have red black tree, right? So either this will be red or this will be black. So when you'll read red black tree, you'll get to know. So this is how the node looks, and you can see like this will be the parent of that. Okay, so this is how the node looks. And since it is a self-balancing binary search tree, so this left will always be logically less than parent. Okay, so why I said logically, so here if let's suppose parent is 2, so left will always be less than 2. But in case of let's suppose the custom object, right, employee, so as per the definition you provide in comparable or comparator, it will compare that which node is less than which instance. So logically it will, the smaller nodes will be put as a left child. And obviously right here, right will always be logically greater than parent, right? So I'll also advise you to read self-balancing binary search trees, because that's also a very good uh, to study, and a lot of questions are asked actually. So couple of things, like unlike in hash map, here equals and hash code doesn't play any role. Okay, so I'm just writing and cutting because you should remember, so they don't come in picture. So moving forward, in terms of time complexity, okay, so since it's a self balancing binary search tree, you already know the time complexity of this type of data structure. So insertion O of login, and for lookup, that is search, this is also O of login. So this is the time complexity of, and this it maintains, so you can say sometimes, let's suppose, so that's why I'm saying that you should study self-balancing binary search tree, because when you'll remove a node, it will balance itself in such a way that next time when you'll search, the complexity will be of login. And my advice is to just go through it, and if I'll ever start teaching data structure on my channel, I'll be covering this topic, but that will be too late for you guys. So I'll say that you should study by your own. And another thing is TreeMap is not synchronized, so it's not thread safe. Okay, however, you can do it using collections dot synchronized sorted map. So you can use this and do it synchronized, but if you need it. And one more property, unlike hash map, this tree map does not allow null keys. And I need not to explain the reason also. There is no mapping in the array and all. Okay, so there is no scope for null keys. But not to be confused, here multiple null values can be there associated with different keys. So if key is, let's suppose, 1, you can put null. Key is 2, you can put null. 3, you can put null. Who cares? So they are there. So with this we covered, and yeah, one last thing we'll cover. You might see that what is the initial capacity. Okay, like in the hash map it was 16, So do you guys even think that does TreeMap really requires the initial capacity? The answer is no, because first of all, tree itself can grow dynamically, right? And if as long as you have memory in your system, you can create a node. So it does not allow an initial size or initial capacity, because it can grow dynamically if needed. So you don't need to have the capacity here. So with this, I think I have covered the internals which are required for your knowledge. And if you really want, you can study iterator and all, because TreeMap is fail fast iterator. And in case of concurrent modification, which I said that since it's not synchronized, it will throw concurrent modification exception. So these things you can study from anywhere, but so far for the internals it's this much. And if you tell even the interviewer this much, you will have a good impression, I mean, that this guy or girl knows the internals pretty well. So at last I'll say the same thing, that if you want to follow me, follow Thriver Ashish, my Insta handle, and Twitter, and even LinkedIn, where I post daily some useful stuff. And these are not my I mean, I don't put personal things so far on this. So all the content is educational. I am not saying that I'll not put personal things. I might do anything in future. So far it's educational content. You can follow me. See you in the next video.